Squares and square roots. Introduction to squares. Square. When we say square, we may get an idea of a 2D shape that looks like this. This is a square shape. An area of square can be written as side into side, as a square will have all sides equal in length. Now, in the place of this side, if we substitute values like 1, 2, 3, and so on, we will get certain results. Here 1, 4, 9, 16, 25. These are called as square numbers. Coming to the area of square side into side, using law of exponent a power m into a power n equal to a power m plus n. If we use this, here side means side power 1. On applying this, we can write as side power 1 plus 1, that is side square. As side is an unknown value, we can write this as n square. In this video, when we say square, we mean this n square but not 2D shaped square. Here in this table, we can substitute 1 into 1 with 1 square, or we can say that 1 raised to power 2. So every value here can be substituted like this. In the concept of squares, we have two different terminologies like square of a number and square numbers. Square of a number means if we have any number n, then square of that n can be written as n square. Just now we have seen that n square is nothing but n into n. So if we want to find square of 2, then we can write 2 into 2, which is equal to 4. Square numbers. Square numbers are also called as perfect squares. A number m is called as a perfect square if there exists another number n such that m is equal to n square. Now let us understand this with help of an example. Is 4 a square number? 4 can be written as 2 into 2, that is 2 square. 4 equal to 2 square. So 4 is a square number. Or in other words, we can tell that square of 2 is 4. Consider this board game. This is a chess board. Chess board resembles a square. In this, if we count horizontally or vertically, we can see 8 squares. In total, we can tell that 8 into 8, 64 squares on a chessboard. So here we can see this square concept. Similarly, if we take snake and ladder, here also we can see both vertically and horizontally we will have 10 squares. In total, we'll have 10 into 10, that is 100 squares. So in all these concepts, we are using squares. Let us take the square of first 20 natural numbers. These are the 20 natural numbers. When we say square of a number, we know that we have to multiply the number by itself or raise the number to power 2. Now we'll have the values here. Observe these squares. From this we can write few properties, and the properties will help us to identify the squares very easily. Now from the table, if we see, none of the squares end with 2, 3, 7 or 8. These digits can't be seen in the units place of a square number. Square of even numbers are always even numbers. From the table we can observe that square of odd numbers are always odd numbers. And then number of zeros at the end of a perfect square is always even. Here check 10 square. It is 100. In 100 we have 2 zeros. So the count is 2 and 2 is an even number. From that we can tell that number of zeros at the end of a perfect square is always even. In application, the number of zeros at the end of the square of a number is twice the number of zeros at the end of the given number. Let us understand this with the help of an example. Consider this number 5600. If we take the square of the number, this is the value we have. In the original number, we have two zeros. In the square of that number, we can see four zeros. The number of zeros have got double. So whenever we have 0 at the end of a number, its square will have double number of the zeros. Now from the table, we can observe that 1 and its tens complement, that is 10 minus 1, 9. So 1 and 9, the square of these numbers end with 1. Similarly, square of 2 and its tens complement end with 4. Square of 3 and its tens complement 7 end with 9. Square of 4 and its tens complement 6, they end with 6. Square of 5 ends with 5, and square of 10 ends with 0. This observation is applicable for all the numbers. If we consider any number, depending upon the digit in the units place, we can tell which value will come in units place of its square. Now consider the values here. 14 square. From the observation we have, if 4 is in units place, its square should have 6 in the units place. Here 14 square is 196, so we have 6 in its units place. These observations can be generalized, and we can tell that square of any number with 1 or 9 in units place will end with 1. Square of numbers with 2 or 8 in units place will end with 4. Square of numbers with 3 or 7 in units place will end with 9. Square of numbers with 4 or 6 in units place end with 6. Square of any number with 5 in units place will end with 5. Square of any number with 0 in units place will end with 0. Coming to the next property. The square of a natural number is equal to the sum of first n odd natural numbers. Take an example. Say we want to find square of 7. 7. So square of 7 has to be equal to sum of first 7 odd natural numbers. Here in place of n, I am just substituting 7. So it should be equal to sum of first 7 odd numbers. We'll list the first 7 odd numbers. These are written here. Now we have to add these. On adding these, we will get 49 as answer. From the table, we can see that 7 square is equal to 49. And the difference of squares of two consecutive natural numbers is equal to their sum. Consider any two consecutive natural numbers. We'll take 9 and 8. First, we will square these numbers, that is 81 and 64. Consider the difference of these two values. It will give 17 as the value. So the difference of squares of consecutive numbers should be equal to their sum. So the actual numbers we have taken are 9 and 8. So we'll add those and it gives 17. Both are equal, 17 and 17. So this particular property is valid. We'll summarize the properties we have seen so far. None of the perfect squares will end with 2, 3, 7 or 8. Square of even numbers are always even. Square of odd numbers are always odd. Number of zeros at the end of a perfect square is always even, and it would be twice the number of zeros at the end of a given number. Take 10. Square of 10 is 100. 10 has got 1 zero, and in 100 we have 2 zeros. 2 is 2 times 1. And the square of a natural number n is equal to the sum of first n odd natural numbers. The difference of squares of two consecutive natural numbers is equal to their sum. And the digit in units place of a square depends upon the digit in units place of the given number. Here if we have 1 and 9 in units place of the number, its square will have 1 in its units place. For 2 and 8, 4. 3 and 7, 9, 4 and 6, 6, for 5, 5, 0, 0.